So now for something completely different, I'm not going to talk about yet another build system or a way of creating an OSGi bundle. I'm going to talk about some of the projects I'm doing. So I'm Tim Verbelen. I work at the university. I'm a researcher there, and we usually work more on the one hand, robotics, and also connecting the robots to AI, artificial intelligence, and mainly deep learning. So when you think about, so you're working on intelligent robots, then people think, I'm doing this. I'm trying to create the Terminator, but that's really not where we're at. So these are more the kinds of robots that we're using. So it's more like industrial manipulators, sometimes on a moving platform that can drive by. You can also see that you're in a research lab by the way that we professionally mount our robots on the table with just a few clamps. So this is a bit our playground where we work with. And so then you probably ask yourself, so how do you guys end up using OSGi? Because it's not something typically you would associate with robots on the one hand, or AI or deep learning on the other hand. But by now you all know that OSGi is just freaking awesome to use, and it's just a good way of developing stuff. And I discovered that way back when I was doing a PhD more on distributed computing. So there I did a lot of OSGi stuff, and I still continue to use it now for any project where I actually can say for myself which is the technology we use. I definitely go for OSGi. And mainly you will do it for modularity, but also because it's industry standards, you have microservices, your code becomes much more maintainable. There's lots of open source implementations, but also they have very neat things for asynchronous programming, and that's a bit where I'm going to touch upon today. And maybe it's already interesting to know that the standards on the async stuff I'm going to talk about, they are not really tied to an OSGi framework. So you don't need the whole tool chain or whatever. You can just pull in the jars and use them as a library in any Java project. So whenever you see something in the interfaces I will show, where we have this nice looking class and want to use it, you can just do so already before you even know how to launch an OSGi framework. So that's definitely something to keep in mind. It's more than just a module framework. We also have lots of other cool specifications. So what do you use when you do robotics? And then especially in research, you end up with the robot operating system, or ROS in short. So it's kind of a set of software libraries and tools that allow you to interact with robots, to interact with sensors. It has bindings for all kinds of languages like C, C++, Python, also Java. And it basically boils down to how can you integrate the robot, the geometry, the description of the robot, and how do you have kind of APIs or kind of messages that you can use to control these. And actually lots of robots come with a driver, a ROS driver provided by the manufacturer. So that's basically the main reason why you use this. So how does it work? It's basically kind of a publish-subscribe system, but then on a process level. So basically you have your ROS core, which is a process on your system. And then you can launch another process, for example, a camera node, and then the camera node says, okay, I'm going to start publishing my images on the camera/image raw topic. And then you can spawn another process, and then this can subscribe, and then this way you can basically get subscribed to whatever the camera is providing you. And similarly, you can have a driver for your robot that subscribes itself to a /arm/position command topic, and then you can start publishing commands to that topic, and the robot will start moving around. Everything goes nice. Now, of course, I want to use OSGi because I have all the nice bundles there, the nice standards, and I can then also integrate it with whatever bundle I used to develop before. So what I do then is basically I start off my OSGi framework, and then in that OSGi framework I then have a bundle which is ROS Java, and that basically acts like another of these processes, and it knows how to talk to this ROS core node and get whatever information. So you can start sending commands, or you can you can start subscribing to the camera images, for example. So that's basically the integration with ROS. And then from there on, you can start using all the nice stuff from OSGi. So for example, I don't really want to bother which topic it is for my robot driver and which is the kind of type of command that this robot needs, because also these are not really standardized. So any robot can expect any type of commands thing. So you have to do this over and over again for each of these robots. But I can just wrap this into a nice service bundle where I say, okay, I just provide an ARM service, and this guy knows how to translate this to the position commands for this robot, and for each of one of my robots, I just built one of these modules, and then all the other bundles just know, oh, there's a robot arm, I know how the service is, it's nicely type safe, and I can start calling it. So that's very nice. I can do the same with my camera service. But then still, you have this like dual world, like there's stuff happening inside the OSGi framework, but you still have to spin up this robot driver and this camera node. They actually have to be there, because else nothing will happen in your system. So we basically also have like other bundles that kind of map to these processes, and they actually control the life cycle of these processes. So for example, if I if I install my camera nodes provider bundle in OSGi, it will just spawn the camera node process on my system. And when I stop the bundle, I will kill the process. So I have like a one-on-one mapping of the life cycle of these processes in ROS with the bundles I have in OSGi. And this also makes sure that I can benefit from all the nice things in OSGi. For example, I can provide configuration parameters, just like Tim showed in his talk. I can provide all the configuration of which is the /dev/video device that this camera needs to be listening on, or what is the frame rate this camera has to publish at. I can all provide this in a nice type-safe configuration object. I give it to my OSGi bundle, it spins up the camera node process, and everything's up and running. I can do the same thing for my robot, for example. So you have a nice OSGi system that controls everything from what's happening in the ROS world, and it abstracts away all the hassle of how can actually send the command to my robot, for example. So the key thing still missing is I have these two triangles here, which are the services that I want to expose. And then, of course, the question is, how do I define such a service? So let's start with our robot arm. So for example, I can say, I have an interface arm, and what do I want to do? For example, I want to set the position of a certain joint, or I want to set the positions of all the joints in one call, or maybe I want to do something with inverse kinematics, where I just give it, I want to go to position X, Y, Z, somewhere in the Cartesian space around the robot, and it should move to that position. But of course, the question is, when do you return this method? Do you immediately return, and then you have to, for example, start polling the arm, where are you, oh, now you're at the position, so I can do the following thing? Or do you just block forever until it reaches that position? But what do you do then when it, for example, hits something and it doesn't reach the position? You can be waiting there forever, you have to throw exceptions. So it's not really clear on what you want, and depending on your use case, you either want to have like fire and forget and it will start moving, I don't care anymore, or you really want to wait for it to complete, and then you can do something different. And for that, OSGi actually has the very cool thing, which are promises. I don't know who knows promises from JavaScript. Yeah, so some of you are familiar with it. And it's actually kind of a similar concept, but then in the Java world. So instead of returning void, you basically return a promise, and the function actually returns immediately, and you get this promise object. And what this object tells you is that there will come something, but I don't know when. And when it comes, I will tell you, and I will resolve the promise with the type that you give here in the generics. And here I return a reference to the arm itself, and this allows me to have this nice fluent API where I can just call one of these methods. I get a promise, and then you can have you can basically say, okay, when this promise resolves, then I want to do the following thing. So for example, This is familiar code now that you know all the notations. So I create my component, which is a controller for my robot. I add in a reference where I say, okay, I want to have any robot arm that's available in my system. And when I get this arm, I want to do something. And I can say, for example, arm.openGripper. This will give you a promise. And then when that promise resolves, when the gripper is open, then you start moving your arm, or you set a position on a joint, or then you move to another position, and then you basically you close your gripper. So this is basically how you can program move your arm to a location and close the gripper action with just a nicely fluent API, and everything works asynchronously. So at the moment that you are here, you will immediately be returned with a promise, and everything will chain and nicely resolve whenever everything's done. And supposedly that something goes wrong, then your promise will fail, and then you also get an exception object, and you can see, oh, where did it go wrong, and maybe I have to do something new to counteract that. So you have a very nice API that you can use for this kind of stuff. So cool, we have this, so let's build a small application with it. So for example, this is one of the robot setups which we have. And so one thing you can then do to one small application that we built is basically that you take the arm, you bring it to a position, and then every time I press the space bar, I just record the position it was, and then you can have like this program by demonstration application. The nice thing, this is then all done in OSGi, and I can basically use any robot arm that I've integrated and run the same application. It comes with a nice user interface that you can create using the HTTP whiteboard and all the other fancy stuff. So basically here you see all the steps I recorded. I also capture some frames from the camera while doing so. So cool. So then I can just say, okay, now repeat it and pick up the block again. And then everything works fine, except dummy mistake. Of course, you don't know where you put the block the first time that you thought that. So then, yeah, what do we have to do? We're stupid robots, so it doesn't work. Of course, this robot arm, it has no sensors from it own, so we definitely need sensors so it can see, yeah, maybe I don't need to go to the position, but maybe there's something I need to pick up, and it looks like this blue box. So let's continue. We need sensors, and then we're back at the previous slide where I had my two triangles. So I have now an API for my robot. I now need a similar API for my camera. So what do we do then? Okay, we can make an interface camera, and we say, okay, I can query the camera to give me a frame, and it can be maybe the latest frame, or I can say, yeah, do a capture now, like you press the button. But that's usually not what you want with your camera. You basically want to have all your frames coming in and process them and react with your robot as the frames come in. So you could say, okay, let's make a listener then, and then I register this camera listener, and then my camera bundle will start calling me with a new frame. And yeah, it's already a bit better, but it's still a hassle to handle. So what would be really nice if you can have like a stream of frames and process it, because who knows the Java 8 Streams API to iterate over collections? Yeah, and it's really way more cooler to do that than do the for loops. Let's say, so for example, on my wedding, I want to know the guests from my wedding. I have a list of them, and I want to know how many adults are there, so I can know how much wine I have to buy. So then you have this nice API where you can say, okay, take this list, stream it, and then you can say, okay, I want to map my person object to the age, and then I want to filter on the age, and then count the number of persons, and then I have the number of adults, which is a really cool API. So that's really what we want with your camera as well. I want to have my camera interface, and I call stream, and then magically the frames come in. But of course, I don't have a list of frames in my camera. They come in as the sensor says, here's a new frame, depending on the frames per second that you configured it. So you really want to have like the stream method, but then things should come in as they are basically pushed into the system. And that's where one of I think the coolest things about R7 is, that's where the OSGi PushStreams come in. So a PushStream is basically exactly that. You give it like a stream of guests, and as your guests click RSVP on the website that you gave them, an event comes in, and then you can process it all the same way as you could with the Java Streams API. However, you don't get your long immediately because you don't know when everybody will RSVP, or when you close down the term, like say, okay, you can RSVP until now, and then you can only do the count. So at the moment that you basically have the stream and you count it, then you don't know it immediately, but we return a promise. And whenever you, for example, say, okay, I close the RSVP site, now you get the promise resolved with your long. And that's exactly the same thing that you want with your camera. So now we have this type that we can use there, and we say, okay, I have my camera, and then I can return a push stream with camera frames, and then the frames I can use stream, and then I can map the frames or filter them or analyze them and do whatever I want with them. So it's really, really cool and very easy to use API. Of course, there's a lot of there under the hood, which I'm not going to cover. I'm not going to talk about that, but there are excellent presentations of Tim Ward where he explains everything nicely. So look it up or read the spec if you want. There's also a nice blog from which I actually just copied the example. So all the credits as well for the author of the blog, being Tim Ward. So now we have our API to have a camera. We can stream the frames as they come in. So then we have to do something with these camera frames. And as I introduced you, I also work on AI and deep learning. So what we do, of course, is just use a neural net. It's good for everything. But so actually, I deliberately chose this picture. So how does a neural net work? So basically, you have this black box with all kinds of parameters, and then you throw a lot of data at it. So for example, you give it a gazillion of pictures of cats, and then you say, this is a cat. And then you try to fiddle out with all the parameters, so it always outputs cat whenever it sees something like that. But what you're actually building is kind of a pattern detector. It will just search for patterns, and when it looks like a cat, then it will say, okay, this is probably a cat. But of course, keep in mind that if you show it a cat that looks like a cat, but although it has no tail, or it has no it doesn't have 4 feet, then as a human you know, yeah, this is not a cat. But the neural net doesn't know, because it says it just sees, well, it has 2 eyes, it has whiskers, it's kind of furry, so probably it's a cat. But anyway, for some use cases, it's actually good enough. So for example, with my demonstration application, I just want to know what is the pattern that I first grasped when I did the demonstration, and I'll try to look for the same pattern next time. So putting everything together, you get something like this. So you can imagine the add references in the code over there yourself, but then you get something like, okay, I have this method called grasp. When I resolve a promise with a Boolean that says whether I successfully grasp something or not. And then I say, okay, I take my camera, I start streaming. This returns me this push stream, and I can say, okay, I add a timeout because I don't want to search forever for this block. So after 10 seconds, I just time out and say, okay, the promise will fail because of a timeout. Then I say, okay, I will map the frames to whatever, to a tensor object, which is basically an array type that neural networks like for process it. Then you forward whatever you have through your neural nets. Then what comes out of the neural nets you use to update your controller that will start moving around. And then it will also return kind of a success. And when you match the success, then you stop your stream and you can resolve your promise with either I had it or I had it not. So if we then try it again, then now it basically knows, okay, there should be something here looking squarey and blue, so this is the thing I should pick up. And if it's slightly on a different location, I'll just adjust my control a bit and also pick it up. Also, if you have some other objects lying around, then it will still know, no, you showed me I need to pick up the blue stuff, so let's do that. Also, when you then start moving around, it sees, yeah, this thing is moving around, so let me just track it. And then you can also do the other way around. Instead of teaching it to pick something up, you can also teach it where to drop it. For example, when I teached it, I dropped it inside my hand. So now it just wait there and say, yeah, there's no hand, there's no hand. Oh, there it is. So there we go. So this is a small example on the cool stuff that you could do with all the asynchronous APIs and how you can actually build a very complex application with it. So thank you all for listening and staying this late. I would also once more like to thank Tim Ward because he really put a lot of effort writing both the Promises and the PushStreams spec. I do encourage you to check those out. As I said in the beginning, you don't need an OSGi framework at all. You can just pull the jars from the Maven repo and start playing around with it in any Java application. And also, I need to thank some of my colleagues which regularly take care for the robots. So this is it. If you have any questions, I'll be around for some time to answer them. So thank you.
Thank you very much for that practical insight into how you apply it also in the science space.
Yeah.
So this is really, for us, which are mostly coming from the industry, really nice to see that we also build something useful for the future of humanity, maybe.
Or not. Yeah, exactly.
So, as already guessed, maybe, we also have a wine for you. So
thank you very
much. And enjoy.
Yeah, thanks.
And questions?
Do you have time for questions?
Yeah, sure.
I have a question. How do you do something like flow control on this push stream? For example, you have a camera that delivers 60 frames per second, but your logic takes more than 1/60th of a second to process.
Yeah, so PushStream have this nice feature built in where you have like back pressure, and every time an event comes to you, you can give it feedback and say, okay, hold on for a second. I'm not done processing the last frame, so try to tune things down. If you get basically flooded, you can also just close down the stream and say you're flooding me. I'll just short circuit and stop. Of course, you can also put other stuff in between, like a buffer. You can say, okay, let me insert instead of mapping it directly and directly processing it, let me just put a buffer in between for some time or some slots, and then you can also control the rate that comes in from the buffer a bit, and then also your buffer will give back pressure to whatever is pushing in there. So if your buffer is almost full, it will start giving more back pressure. Of course, this only works when you actually have control a bit on the events that come in. For example, you could say in a cloud-based system, you could use it, for example, to spawn up another instance and then start queuing, for example. In this case, you basically, what I do here, for example, is just have a buffer with one item in there, and and I just keep the last one, and the others I drop. So basically, you're constantly processing as fast as you can, and yeah, if I miss something in between, then you basically drop the frame. But all these things you can then configure by doing buffers or do windowing or coalescing. So you can all do all these kind of fancy stuff with the push streams. It's all there in the spec, so do check it out. Yeah.
Thanks. Did you mention the name of the library that implements these push streams?
Say again?
Did you mention the name of this library that implements this stuff?
It's org OSGi util pushstream in Maven Central. Just search Maven for OSGi pushstream and you'll find it.
Yeah.
By the way, our slides that you've seen today, will you publish them somewhere?
Yeah.
Okay. So maybe if you then have the link to where you want to publish it, just send it to me.
Yep.
And I will put it on the meetup page, all the links in the comment section. So if you didn't grasp, right, for example, the framework, URL or something like that, you can look it up afterwards.
I might add the slide with all the references to where you can find all the stuff, so I'll add another slide so you can see it afterwards.
Okay. More questions?
What is the advantage of using OSGi for this stuff? For this push stream?
Well, the nice thing is that it's also integrated. If you, for example, all the interfaces I showed, they're also like a service in the system. So you can provide an implementation for it. You can provide any implementation for each of the robots. Have a different bundle. You can spawn them up together or only one. You can do all the cool stuff that Tim and Jürgen showed in the beginning in the first 2 presentations, but now also do asynchronous processing with it. So they're already great as standalone libraries, but they're even more awesome when you use them inside an OSGi framework.
For these two, as mentioned, we specifically designed them to not need the rest of OSGi, right? So they're just utility libraries. You can deploy them and use them in any job application. They don't need an OSGi framework. They don't care about modularity in any particular way. And so we designed them to be sort of very small and concise and focused to do the particular job they're doing. We also, as Tim mentioned, we use them in other parts of the system. We have other APIs that return promises. Our asynchronous services model for doing asynchronous service calls returns promises. We use the PushStreams to do logs. So if you want to subscribe to the OSGi log, you can subscribe in the form of a push stream of log entries. So it just pushes log entries to you if that's how you want to consume the log. So we try to use it in the rest of the system, but we also said, hey, these are useful even without the rest of OSGi, so we carefully put a lot of effort into making them very focused and narrow and useful. So I mean, if you look at Java, you can see they have completable future, but if you've looked at the completable future API, it boggles the mind how many methods are on that thing. It's unreadable. And so Promises basically does the same sort of thing, but it's much more compact and direct. And if you have any experience with Promises out of JavaScript, it will immediately be obvious to you how it works.
I also have a question. What's the goal of your research? So I think there are certain topics maybe, or
yeah. So the grand goal is to make robots be aware of the environment around them and being able to interact with the environment around them just by processing the sensor input. So now this was more like a very concise case where you do one demonstration, it has to repeat it and do some small adaptations, but we also have like more experimental research where we just say, okay, here's the camera stream and start learning from it and start poking around and try to learn how the world works, for example. So this is the range of topics that we're doing work in.
So does it kill anybody that walks into its range of motion?
No. It's no.
Okay. Good then. I think we can close it for now, as I see it. Or are there any questions directly for the crowd? Currently, this seems to be not the case. So then I would like to thank, of course, all visitors, and also special thanks again to Johannes for making it happen here and giving us the opportunity and the space and also the riches and
yeah, I convey it to the whole company.
Okay, that's awesome. Thank you. So, yeah.